Okay, so this is the second optional optimization problem that we're going to look at. There's something similar, I think, in the homework I gave you guys. So we know it's a parabola, and we want the closest point to 10, 0. So note that you're going to basically be dealing with a triangle, and it's really, you're changing in your delta x and your change in y. So really Pythagorean, because if you move the point this way, it decreases. So this would be shrinking your y, delta y. And if I'm moving this way, you're going to be going up, and it would be shrinking your delta x. So it's trying to find what's the optimal position this will be, so it would be closest. Is it down here? Is it up here? But you can see going further away, it makes it longer. But no matter what, if I'm moving it up, you're going to make it a triangle smaller. But you can always see that if you move it way over here, you're going to be dealing with a very big triangle, right? So you're trying to find really a small triangle, which is really using, of course, the famous Pythagoras. That's all it is. Squared, right? So let's just put that in. So I'm going to call it length, which is my L squared. So that's my hypotenuse. And it's going to be just my delta x squared plus delta y squared. This will then be L is equal to square root delta x squared plus delta y squared. This is going to be L is equal to x 2 minus x 1 squared plus y2 minus y1 squared. There we go. Right? So now I plug in the point that we have. Sure. So that will be L is equal to this would be just my x. So that is the x that's just moving all the time. So that would just be my x that moves minus the 10 squared plus y, which is the one that moves. And that would be just squared because this is 0. So, okay, so then I just have that. But notice also we have y equals x squared. Well, perfect. That means right here, this thing can be this, x squared, which is simply 4x to the 4, right? So, okay. So then we really have an L that is square root x minus 10 squared plus x 4, right? So, okay, that's what I got. Great. I can now take the derivative of this. Let's take the derivative of that. Sure. That's going to be 1/2. This is going to be in here. Actually, it might be nicer before we even, might be nicer to do this. Before we even take the derivative, let's expand this. We're going to expand it because it's nicer, just nicer to work with. So this would be just x squared, right? Minus 20x, and this would be plus 100. Plus x, right? So then, if I take the derivative, L prime, well, that's just going to be 1/2. And then don't touch anything in the inside. times, now take the derivative of everything on the inside, which is just going to give me plus 4x cubed. There we go. That's everything on the inside. So great. So really, oh, by the way, we just need to make sure that that's a half. So I'm just going to mark this stuff in, this is stuff in red, and this is going to be stuff in blue. Okay? So really, if I rewrote this L prime would look like this. L, there's the 1/2, divided by stuff in red, which is on the bottom. So this is square root stuff, right? And then on top, we just have the blue stuff, right? So that's what we have. That's what it basically looks like, except I'm just being lazy and not putting in the polynomials, right? So, but now what we want, set L prime equals 0, because we're looking for a max or a min. So we're playing the same game. So that would just mean, notice that this, if this is equal to 0 right here, that means all we really have is stuff equals 0. So really, cross multiply, you'd have stuff equals 0. So notice what you have. I'll rewrite it. Stuff blue. All over stuff red is equal to 0. Well, really, all you're going to have is really stuff equals 0. So what is that stuff? Okay, well, stuff then is really just 2x minus 20 plus 4 x cubed? Did I? No, what did I do? Oh, right, because, oh, well, what you can do here, because notice there's equals, we're good. So we're good. Notice that there's a 2 in common with all of these. So what you can do is just pull out the 2. So you can pull out a 2. 10 plus 2x cubed. 0. Okay, so this is actually what we want. So the equation so far, what we have is just this. Because cancel both sides by 2, or divide both sides by 2, you'd still have, we just now have x minus 10 plus 2x cubed is equal to 0. Right? So that would then mean, here's the point. So we've gotten to this point, no GDC, right? So this is at this point, no GDC, right? But can't go further. Can't go further without GDC, but need GDC. So this would be a paper 2 question. So what I do with this is I put, there it is, I put it into the calculator, boom, put that in, and I find my zeros. There it is. So what does that mean? So I know there's going to be, if it's a 0, I know I'm going to have a minimum or a maximum at that point. Now, the thing is, you can, because you have a GDC, you don't have to do the sign diagram. Otherwise, I would have to do this, right? At 1.61, I would then test, and this would be my L prime of 0. What's happening on either side of that point just to find the minimum? Well, I'm lucky enough I have a GDC, and I can actually plug in that expression, my L, right? So we're going back up. There's my L that I plug in. Actually, go back up to my L. There it is. So here's my L. So I'm actually plugging that into the calculator. So it's right there as I showed you. And then what do you see? Well, it does this funkiness right here, and it dips down again and up. There you go. And then right at that point, we can see that if we put numbers in on either side, that would be negative and that would be negative. Or sorry, that would be positive. Right? Because you can see there's a negative down here and it's going up again on that side. So right here at that 0, that is my mind. There it is. Haha. And guess what? If I put that into my original function, I know exactly the distance. So therefore, and I would sketch this in the problem. So I'm just using this because I have technology and I can do this, but this I would actually sketch and have this part of my problem. So I can then, therefore, we can say closest point, it's L is closest when X is approximately, I'll even put approximately 1.61, since L 1.61 is approximately 8.78 units. And you're done. That's it. So that's how you do that problem.